Hello everyone. Today we are going to look on a video on basic power amplifiers. What are power amplifiers? An electronic circuit that enhances the strength of an incoming signal is called power amplifier. The power amplifiers basically takes the signal from the DC power supply connected to the output and converts it into an AC signal. I'll just draw a simple block diagram to explain how power is being amplified. The input signal, whichever you want to amplify, is fed into a voltage amplifier. Yes, the output of this is again fed to a driver stage, then to an output stage. And hence it is fed to a particular output. So the input signal, for example, if it is of this kind of amplitude, is fed to a voltage amplifier. What does these amplifiers do? Voltage amplifiers are quite having a small difference between themselves and power amplifiers. Voltage amplifiers are low level amplifiers and power amplifiers are amplifiers which increase the amplitude of higher level of voltages. So when this is given to a particular voltage amplifier, the amplifier increases the amplitude of the signal. It depends on the type of amplifier we are using. If it is of a common base, we will be getting this kind of amplitude. If it is of common emitter, the amplitude is an increased with 180-degree phase shift. This kind of amplified signal is fed to a driver stage. The driver increases the strength of the signal and it connects the input stage and the output stage. So the output stage is prepared, the signal is prepared to be delivered to the output. For example, most common application of an amplifier is a speaker. When we want to increase our sound signal, we just try to give it to an amplifier and we'll be getting the output, an amplified output at the other end. So a speaker is an example shown here. The amplifier efficiency depends on the ratio of the AC output power to the DC power input. Efficiency is equal to AC output power divided by input DC power into 100. So when this kind of performance is done, there are possibilities of distortion. The change in the output wave shape from the input wave shape of an amplifier is known as distortion. So these power amplifiers are classified into different categories based on how they are amplified, based on the strength of the signal and based on the phase shifts. So based on the frequencies, first we'll discuss the types of amplifiers based on frequencies. Yes, based on the frequency, they are classified as audio power amplifiers, and based on frequencies, they are classified as audio power amplifiers and radio power amplifiers. Audio power amplifiers are amplifiers which increase the signal working in the range of 20 Hz to 20 kilohertz. We know that the range of the audio signal is 20 Hz to 20 kilohertz. So the amplifiers which are working with this kind of frequency, 20 Hz to 20 kilohertz, are called audio power amplifiers. Radio power amplifiers are those amplifiers which are working with a signal range of 3 kilohertz to 300 megahertz. 3 kilohertz to 300 megahertz are radio signal frequencies. So those amplifiers which are working in the frequency range of 3 kilohertz to 300 megahertz are termed as radio power amplifiers. These are otherwise called as tuned amplifiers. These amplifiers are otherwise called as tuned amplifiers. Yes, so this is classification is based on frequency. We have another classification based on the modes of operation. So depending on the operating mode of the amplifier. Generally we use BJT for amplification. Further developments have been used with other semiconductor devices too. So in this video we'll be discussing how a BJT under NPN configuration with CE is being used as an amplifier. So under different modes of operation, if the portion of the input cycle is converted, then the mode of the operation also changes and the type of the amplifier is also changing. They are named as Class A power amplifier, Class B power amplifier, Class AB power amplifier, and Class C power amplifier. In Class A power amplifier, the conduction is taking over a complete 360-degree. In Class B amplifier, the conduction takes place over 180-degree. In Class AB power amplifier, the conduction takes place from 180-degree to 200-degree. In Class C power amplifier, the conduction is less than 180-degree. So this is the basic classification of power amplifier. We'll discuss about power amplifier efficiency. So as we have discussed, when an input signal is fed to a amplifier block, this is the input signal. It is fed to an amplifier block. If it is of a small signal, it can be later sent to a power amplifier block, and this is fed to the output. For example, if we are using a common emitter amplifier and the signal is amplified, we'll be getting an output signal of this form. And in order to give proper biasing for the BJT, we need DC power supply fed to the amplifier circuits as well. For the purpose of biasing. And based on the power amplifier types, we have Class A, Class B, Class C, and Class AB types. We'll be discussing about this one by one, the modes of operation. Class A amplifier. The commonly used type of power amplifier is Class A power amplifier. I'll draw a circuit diagram of a Class A amplifier. We have already discussed this kind of circuit in our previous video of types of amplifiers. Input signal fed to the base, the emitter terminal, through the help of a resistor, RE resistor, and we need to give proper biasing. So we need not by heart any circuit diagrams. If we understand the circuit diagram very clearly, the basics, we'll be able to draft it ourselves. So first we are feeding an input signal. Input signal cannot be directly given to the circuit, isn't it? We need to block the DC. So we need to connect a blocking capacitor and we need to give proper biasing. So this kind of biasing we are familiar with. What is the name of that biasing? R1, R2. It's voltage divider biasing. Fed to the base. And we have RC resistor, RE resistor with another coupling capacitor, and the amplified output. And the amplified output is taken across the collector and ground terminal. So output across VCE, the output voltage is signal taken. So now the amplified output will be 180-degree phase shift. We'll be having a phase shift of 180 degree. Yes, how do we realize this? Yes, we will try to observe. At the during the classification of amplifiers, I told that they are operating in different modes, and class A amplifier has a complete shift of 360 degree. How do I say that? So that is observed from the output characteristic of the BJT. Taking VCE on the x-axis and collector current, we know the DC load line. We have seen this in the DC load line, and at the saturation levels. Yes, at the stability point, these points are quiescent points, and if geometrical horizontal and vertical lines are drawn, so let this be Q1 and Q2. Yes, if the input signal is given in this manner, the output signal is obtained for a complete 360 degree. Output characteristic with the operating point, that is a Q point or the quiescent point is shown here, and the VCEQ, the saturation limit, this point is called VCEQ, and this saturation limit is called ICQ. With the saturation limits are mentioned here, the output current increases to IC max and decreases to a value of IC minimum. Q1 and Q2 are the point shifts when the signal is applied. Similarly, the collector emitter voltage increases to VCE max and decreases to VCE minimum. So this kind of classification is a class E power amplifier. The characteristics also we have observed. Direct coupled, the next category is under class A amplifier. We have two types of class A power amplifiers. One is direct coupled, the other one is transformer coupled class A power amplifier. Yes, so the previous diagram which we saw is a common direct coupled class A amplifier, and we'll try to observe the operating range. If it completely gives an output signal of 360 degree, the RMS collector voltage, that is VC is given by VC max minus VC minimum divided by 2 root 2. Yes, which is equal to VCC minus VC minimum is 0 divided by 2 root 2. The RMS collector current is given by IC is equal to IC max minus IC minimum divided by 2 root 2, which is equal to IC minimum is 0. So the value is 2 IC divided by 2 root 2. So the power, the AC output power which we get is VCE into IC. VCE into IC. It is VCE into IC, which is equal to VCE we have calculated as VCC divided by 2 root 2 into IC we have calculated as 2 IC divided by 2 root 2. So we will be getting VCC 2 times of VCC IC divided by 8, and the AC output power, this is AC output power, and the next one we'll try to calculate the DC input power. DC input power is VCC into IC. This is VCC is the DC biasing that we have given, and now we'll calculate. We'll try to calculate the efficiency. I have previously written the Formula for efficiency. Efficiency is equal to the AC output power divided by DC input power. It is given by, on solving, we get 2 VCC IC divided by 8 VCC IC, which is into 100 percentages, and then into 100 percentage we get 25 percentage efficiency in direct coupled class A power amplifier. So this is the efficiency that we have obtained by calculating, by analyzing the circuit. We determined the value of AC output power, we determined the value of DC input power, and hence calculated the value of efficiency. The next type of class A power amplifier is the second type of class A power amplifier. It is transformer coupled class A amplifier. So what makes the difference in the normal direct class A power amplifier? So I'll just tell you here. Where do we collect the output from? The output is collected from the collector terminal of the amplifier. So what is the modification made in this circuit is, in the collector terminal of the BJT, a transformer is coupled, amplified, and the amplified output is obtained in the output. Yes. And in order to provide a proper biasing, this is RE resistor provided with a coupled capacitor, R1, R2 resistor. This is a blocking capacitor, input source voltage. Yes, for the purpose of biasing, plus VCC. Here, as we know, base terminal, collector terminal, and emitter terminal. Why the name transformer coupled class A power amplifier? A transformer part is connected to the collector of the amplifier, through which the signal is being amplified through particular transformer with n:1 ratio turns, and the amplified output here behaves as the load resistor or speaker. Hence the name transformer coupled class A power amplifier. This transformer used in the collector circuit is used for impedance matching. The load resistor RL is the load connected in the secondary of the transformer. This is reflected load in the primary of the transformer. The number of turns ratio R N1 is to N2 is equal to N is to 1. So let V1 be the primary voltage and V2 be the secondary voltage. I1 and I2 will be the primary current and the secondary current respectively. Now we'll try to understand the efficiency of the transformer. Since the involvement of transformer is held over here, the VCE value is equal to VC max minus VC minimum divided by 2 root 2, which is equal to VC max will be equal to 2 times of VCCD, and VC minimum is 0 divided by 2 root 2, and the current, IC current, is equal to IC max minus IC minimum divided by 2 root 2. IC max in a transformer coupled amplifier, the IC max value will be equal to 2 times of IC, and IC minimum is 0 divided by 2 root 2. So calculating the AC output power, TAC is equal to VCE into collector current is equal to 2 times of VCC divided by 2 root 2 into 2IC divided by 2 root 2, which is equal to 2VCC into 2IC divided by 8. And EDC is equal to VCC into IC. And next is to calculate the value of the efficiency. Efficiency is the AC out ratio of AC output power divided by the DC input power on simplification. With this, the efficiency of the transformer coupled class A amplifier is determined to be 50% efficiency, and this is the impact of the transformer being connected to the collector terminal of the amplifier. So which shows that a class A amplifier is capable of giving an output signal of 360-degree complete cycle is obtained. And there are two types of class A amplifier: direct coupled class A amplifier and transformer coupled class A amplifier. Direct coupled class A amplifier, we observed that the efficiency is only 25%, and in transformer coupled amplifier the efficiency is 50%. Thus, this shows an improvement in the efficiency of a transformer. This is all about class A power amplifier. Thank you.